Hello and welcome back. My name is Ahmed Al Jawad. I'm the CCNA instructor for TechPix.net. Here today we're finishing our TechPix CCNA training. Last time we talked about the host data flow is going between two hosts and how they're using the ARP and the MAC address of the communication, and we show you that in GNS. We pretty much covered all the first sections of the Cisco exam topics. We're moving to the switching. I might go back later to do more explanations on the Mac and the other protocols like three-way handshake. But I'm as I said, I'm putting this videos uh, in the way that I don't have any training material. So I'm going out with you guys to look for all the training material out of the internet and put them together for any of those who's out there trying to find training material and they can't afford buying all the professional training material. So we going today for the switching, and when we get to here to configure, here where we start having a lot of fun, because we've been talking a lot. Just keep talking, keep talking. Now we're actually going to start doing hands-on, because I think you mentioned, you guys, like I kind of don't like do a lot of talking, because especially in these like sections of technologies where they're explaining a lot of theories and how does that work. There's a lot of other videos on YouTube and other topics on the internet and Wikipedia. We can go and find them, and just why I'll cover them again where there's a lot of other people cover them. So, but when we get to the configuration, I will actually start doing a lot of configuration and explain to you what the configuration, how it work. So kind of excited we are getting to the configuration, and now let's keep going with the switching. So first topics in the switching is determine the technology and media access control for Ethernet network. So easily you just have to go and find that on the internet. I did some search. Let me see which one I did. Okay. Ta-da-da. So let's start right here. Okay, you remember the data link layer and the OSI layer, the second layer? That's where kind of you start accessing your network platform. Of course, the physical layer is the actual interface and the cables that you're using to access the network, but like the encapsulation start and all that process starting in the layer 2. The layer 2 actually has a lot two sub layer, LLC and MAC address. Just go and look for them on the just Google the layer 2 LLC and MAC address, MAC sublayer. You'll find a lot of information. I found this on the Cisco Press, kind of very good topic, and it's actually telling you what is the media access. But in general, there's two sublayers: the LLC layer and the MAC address layer. And under the LLC layer, there's a lot of under the physical and the data link layer. If you see, there's a lot of technologies, a lot of acronyms under it. And what is this is because the Ethernet start at the 10 meg per second. When they found the Ethernet protocol, they built it with the speed of 10 meg per second. But then after that, they wanted more speeds because the applications start being greedy and start consuming more bandwidth. So they came up with the fast Ethernet, and then it gets more consuming, more greedy, more consuming, more bandwidth. They comes with the 1 gig, and now we're on 10 gig, and there's even more than that. And usually when you are putting the 10 meg or the 100 meg or the gig, usually it depends on the distance between your host. It's the same. It can be the same cables and the same look like interface. The difference, like the interface itself, is a little bit have a lot of more advanced technology inside it and more advanced capabilities to handle all the traffic inside it. but you are using the same RJ45 cable or optical cable if you are going to a distance. Usually optical is not 10 meg, optical is not supported for 10 meg, is I mean, I won't say, I'm not sure if there is 100 megabit per second. You can run it in 100 megabit per second. It doesn't matter with the fiber. So yeah, you can even run it in 10 meg. So it doesn't matter. It's not for the cable anyway. Just cancel that. So it's the same cables, the same interface, just different how that interface is designed to handle how much traffic. They started with 10 meg and now we're all the way. I think there's even 40 meg now in the data centers, and the 10 meg. There's 10 gig specifically now for the fiber channel technologies, which you guys are going to take about the fiber channel later. So here's what's the data encaps. The LLC sublayer handle communication between the network layer and the MAC sublayer. So it's kind of the messenger between the network layer and the MAC address layer. LLC provide way to identify protocol that's passed from data link layer to network layer. In this way, the fields of the MAC sublayers are not populated without the protocol type informations. So this kind of, the layer that between the MAC sublayer and the network layer, or the network layer's layer, the layer 3 that's going to be above these two. So this kind of the messenger that's built up and kind of do the encapsulation of the protocol between, just to tell them, what, this our protocol, this HTTP, not HTTP, HTTP is another layer. So there's a lot of protocols going through the layer 2, and just giving him the protocol to the network layer. MAC access control, because the Ethernet is shared media and all devices can transmit at any time. Media access is controlled by method called carrier sends multiple access with collision detections. That's kind of important in the shared media, like when you use 10 megabit per second on a hub, not on a switch. They're using the Cisco CD, and on the Cisco CD, I found I found a book. I found a couple books on Safari, and I found another books on another CCNA wiki. I'll include them in the subject of the videos or in the description of the videos. So Cisco CD is like you are on a shared network segments. I mean, imagine this is a hub, like right here down, and they're all connected to one hub, and two of the computers on the same hub trying to send at the same time. They're trying to transfer traffic like this, trying to send traffic to this, trying to send traffic to this, because they're using shared media. Collision will appear. The collision and MAC will drop the traffic, but when traffic is dropped, will send a signal to all of the PCs, and the PCs will start jamming the communication and start a random timer. Each one of these start a random timer, and when the timer is expired, it will send the traffic again, and that's what's avoid the collision in the second time. Now this actually now it's going to tell you where it's used. It's used in the half and full duplex Ethernet. So for example, now we would use, I said it's kind of an old technology. You won't find a collision. I was wrong. No, you're going to find a collision in the access points in the wireless communication, because the wireless communication is a shared media. So when you are connected with your family or a lot of other members, for example, in your work, you are using the same shared media, which is the 2.4 wireless access points, and whenever the collision happens, this will occur. That's why the wireless is slower than the wire connections. That's one of the reasons. Wireless have can has a collision or overlap signals that occurs and will make collision, and need to wait for the host to do the jamming, all of that things. Now, there's more than, here's what one of the things I want to point out for you. It's the type of media that's used. So there is an organization, it's called IEEE. IEEE is the organization in charge of the standardization all over the world, and I mean not just in network and a lot of other things, but in networks. It's the organization that's for the standardization. So this organization adopted the first Ethernet, which they call 10 base 2, So if you go to IEEE and look for 10 base 2, will give you all the documentation for it, and I will here show you what the technology is. So that's very good. Actually, we have a lot of information. So 10 megabit per second baseband technology up to 185 meters in length. So the cable in theory can hold up, can be long as 185 meter. That's like 400 foot, I'll say, maybe around feet. Sorry, I was sorry. Uh, and known as a what is that, thin net, and can support up to 30 workstation and signal segments. Well, you can put actually more than 30 workstation, but you know the jam and all that things will be ugly. So just recommended that you can support more than 30 workstation. Use physical and logical hub bus with AUE connectors. The means 10 means 10 megabit per second. Base mean baseband technology, and you know there's a lot of others. You can finish up, and then 10 base 5. What's the difference? That's 10 base 5 up to 500 meters in length. We are like the most common technology you're using is 10 base 2. You won't find a lot of 10 base 5 interfaces out there, so I don't think, or cables, so I don't think you're gonna find them. 10 base T, category 3 UTP wiring, you know, base 2, they're going to ask you about this in the exam, so you have to go through them. And here we go when they move to the 100 megabit per second, 100 base TX. You know, that's when you use Cat 5 cable, wire pairing, you know, and do, it's still the same distance, but it's more speeds for you. And use the RJ45 connectors with the physical start topology. And here's the fiber technology start coming up here. So it's 100 megabit fiber, and it goes up to 12 meters long. That's with the single or multi-mode, I guess. And there is the other technology that can goes more. 22 meters, and there's a lot of 3 kilometers right here, the LX. So that's in general the media access. That's the network use. Go back to Cisco. That's the media access. Now we're going into the switching to explain a lot of things. Which supposedly I do a lot of explanation in switching, but guess what? I hate it. I never go with the details of my real life when I work, but I have to cover them. So identify basic switching concepts and the operation of Cisco switches. Collision domain. I'm kind of pretty sure I talked about the collision domain and broadcast domain on my first video. But in general, if you looking for them, you know, too easy, just YouTube collision domain. You'll find a lot of good YouTube videos about them. Anytime, soon. Here we go. So how many collision domains show you? That's a lot of them. CompTIA. There's a lot of good ones, and the same thing for the broadcast domain. The ways to switching. You can just Google ways to switch, and you'll find very good documents on Cisco.com will explain the ways to switch. You have to cover this for the exam requirement. Usually in your day-to-day job as a network engineer, you don't need to think of all that. That's all configured by default. You don't need to change anything out of that, but you have to know them. So just go through them for me as I'm putting it for you for your after finishing your exam. You won't need this, so just you have to read through it. Just find out all the information that you need in your exam. Okay, what the hell? I don't know what the hell is this. What have to do with this switching? What have to be connected somehow? I have to read through the documents. Now let's get to the fun part. Configure and verify initial switch configuration. Include remote access management. Da 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 da. GNS, GNS. Let's go to our trusted friends GNS and start doing what they ask us to do in the back there. So let's start with the switching. I like hands-on experience. I like work on labs environment. I like it. So ta-da-da. Just close that in the back. Let's save, save, save. I don't have to save traffic chat capture, no. All the other ones. So switching. Alright, I don't know why it doesn't want to save, but anyway. Well, if you know GNS doesn't support switch in our like switch terminology with Cisco. You know the switch itself that has like all the interfaces and all of that thing. So 24 interfaces or 48 actually doesn't even support the iOS of the switch. That's why we have to use a router. And if I have 2960 here. And what we're doing, because we have a lot of routers models, it has in the back. Let me show you what I'm talking about. So if you go to the slots and you're trying to add the 16 NM16 Ethernet switch model, let's Google this and I'll show you how this look like. NM was 16 or dash 16. Alright, dash 16 switch. Here, Ethernet switch. Here we go. So what is this is actually kind of a slot or extra port that you could put in the back of the router, and this is going to convert the router to router/switch. So if you are in a small office that you have no more than 16 or 15, or not more 16, because what you have here is 16 port. So if you have no more 16 people, why you are going to buy a switch when you have the ability to save some money and some management headache, and just put 16 switch port model in the back of your router. So this is where GN is coming from. They don't have a switch supported, but they have the support of the router that can take this NM16 switch model. So you have to hit OK, and then we'll start the router. And you know what? I'll make it a little bit more fun. I'll change the router icon to make it look like. Change host name, change symbol, make it look like switch, where the switch, ATM. Wireless LAN controller, way, Ethernet switch. Alright, just so make it look like Ethernet switch, you go to the right click configure, and not configure, sorry, console. We are trying to access now the router or the switch for supposedly. So just I'll go through that to change it. So as it began, for example, you're working in a company and somebody called you from the managers or whoever user is, and they goes like, we need a new switch to be configured and sent out to the site. And he goes like, sure, why not? We'll order the switch. You go to cisco.com, trying to find. I just need to keep this. I'll show you how you actually can pick switch type. You go to the products, all products, you go to switches. There's a lot of different model of switches, but you are, as a network engineer, you have to put the best requirement, or take the best requirement from the end user and put them in a way that's fit his desire of the switch. So usually if you are working on a not combat, but the core distribution switches, let's hope that it have the 2960, because I want to show you the access switches. Okay, so combat LAN access switches. So usually you have to keep in your mind what you need, how many ports first. With the speed, do you want the speed to be up to 100 megabit per second or gig? One of the best solutions you have is the 2960s. The 2960 is widely used, one of the most successful switch in the history of Cisco, and that's what actually most of the time you need it for the branch offices. But for data center and like headquarters, you'll need more advanced switches like the 4500 right here, or 380, 3850s. Depends on if you want layer 2 or layer 3. Usually 2960, they're all layer 2. There's no layer 3. So you click on the 2960 link, and then you have to start pick what kind switch you want. You come to compare model. Click on compare model, and it'll show you like what the difference right here. You have to pick when you put your order. For example, you go to CDW and contact their sales representative. He'll ask you for the part number here, the model number. What's the difference first? The first thing is the ports. You have to know how many ports, what these ports support. If you see that's our 2960s X, the new generation of 2960s, there used to be just 2960s, and with the 2960s only without X, we used to have 10, 100 only. Now they all support 10 meg, 100 meg, and a gig. So first thing, do you want a 48 port or 24 ports? So yeah, of course, for example, if you have kind of a big branch office, you'll pick 48. Then how many uplinks you want? Thank you, Google. How many uplinks? And by the meaning of the uplinks, hold on, I have to get this on the video as usual. So the uplinks is how you are connecting your switch to the router, for example, or to another switch. I have to, let me just switch. You know what I have, or we call them Cisco stencils, and these actually very cool cause it can show you where's that Cisco. No, I'll open him. I have him somewhere, sorry. Just wait for me a little bit. There's somewhere. I have to find them. You know what? I'll stop the record, and then I'll come back later. Okay, so back. I'm in the video. There's something called Cisco stencils, and this are like any product stencils, and the stencil is actual the picture of the products. You go to cisco.com, just look for Cisco stencils for Visio. I'll give you that. You have to import it in Visio, and what gives you, like here, it will give you another tab. You could pick like Cadillac 2960s, and for example, we are looking for the C2960X84TDL. Sometimes available, sometimes not, but most likely you can find it. This one is 2960 plus switch, 8 port, POIT, SFP. I mean, this looks like we have to look through a lot. I just don't want to waste more time. Uplink, trying to find like ATLS, that's 8 ports. 8 ports. 2960X. See, we get into the model, the new one. So 2960s, 4 SFPs. Alright, so after you put your requirement, this one is 24 port, not 48 ports. And you can see, just have to a little bit zoom out. There we go. So when you get your switch, the switch will come to you like this after you pick what port number and then how many ports you want. For example, let's say we want 24 ports. How many SFPs or the uplink? The uplink is SFPs. The SFPs, that's the fiber connectors that you can connect through a fiber cable. And here's how it look like. These parts to the sides. These what the SFPs look like, and what this used for. There you can just bring a computer and connect it to here, because the connector is not supported on computer. It's not RJ45. It's actually a fiber cable. You have to buy what we call SFPs that can connect to the fiber cable and plug the SFP in one of these ports. And just so I can show you how the SFPs look like, SFP here. So you buy one of these SFPs. It has two. That's what how's the. I think that's the LC cable. SFP gotta be LC or FC. That's what it's called. And you bring the fiber cable. Put the fiber cable left, right in this port right here, and then after that you bring the whole things and plug it in here. And for example, you have another switch to want to be connected to this switch, you connect through the SFP to SFPs. That's why it's called the uplink, because these uplinks actually can go to another switch only or directly to a router. But of course, if you connect it to a router, the router has to be supporting a fiber. I haven't seen a lot of router support fiber, so there have to be some kind of core switch that has fiber connectors, can connect all the access switches. So you choose the uplink, and then after that you said, like, you know what, I want 24 to LAN base. They're all LAN base, there's just one light. And then do you need a PoE power for it? Well, the PoE power for it is actually using power over Ethernet. So you're sending a power over the wire of the Ethernet. And the way this goes, because usually you know that the Ethernet cable, there are 4 pairs of cables. The Ethernet usually using just 2 pairs. I mean 4 wires to transfer the data, and the other 4 wires they're not used, and they use them now to transfer a power. And this power can be very useful when you have an IP phones or you have an access point. Self stack optional, plus if you want to stack them or not, and other things. And there's more other models you can pick from the 2960. So you picked your model on the 2960. They sent you the switch. The switch look like this, and they ask you to configure the switch. So what you do here to the left, it depends wherever it is. Like sometimes it's in the back, depends on the model, or if it's router or a switch. You can find what is called a console cable. Usually you can order the console cable with the switch, but you have to have a console cable around all the time. You bring the console cable, and I have to show you how the console cable look like. So you bring your console cable and connect it to the Cisco switch to access and start configure the console cable. If I can spell it right, the console was wrong, but anyway, here. That's how the console cable look like all the time, and this is how the connector on the end is RJ45. That's where it goes to the switch, and this where it goes to your computer. But you have to have this kind of a connector in your computer. Usually you don't, so you have to buy a converter. USB to serial is available, so you buy them connected here and put them on your computer, connect the other end to the Cisco switch, and then after that you download, for example, a PuTTY or any hybrid terminal access, and you access through the console. And when you exit through the console, it will take you to here. Of course, you will have to wait for all the promise to finish. So this is how you are actually accessing the cable. Now let's go back to Cisco topics, see what they want to cover right here. Alright, first, configure and verify initial switch configuration, include remote management access. Okay, how we can configure this? First, let's configure a host name. So after you get the switch and you access through the console, you go to your console, you have a different you come to here. There is another mode before this. It's called the privilege mode. Not privilege, sorry, I forgot the mode. Let me just remember what the name. I'll be back. Hello. Let me see if I stopped the recording. I think I did. And what's really I hate about these when they're not. Auto-hide toolbar, go. Okay, sorry for that, I'm back. So at the Cisco.com, we'll show you actually the way how to configure the initial configuration for any switch. So step 1, at the terminal prompt, enter enable. We actually, with the GNS, we are already in the enable mode right here. When you see this sign, the pound sign, that means you are in the enable mode. But before that mode, you have the initial mode, and the to enter the privilege exe mode, and that's what the privilege exe mode, that's where we are at now in the GNS. When you see the pound sign, that's meaning you're in the privilege. What the difference is with that mode in the first tab, you don't have a lot of, you actually can't do any configuration or any change to the router. You just can, or to the switch, you just can actually do show commands, and we can because I'm on the console, that's just not, and that's GNS, so it's just not taking you. I have to show you on the real equipment. But anyway, to enter the configuration mode, you have to go to type enable, and then it's going to take you there. Of course, you can set enable password. I'll show you how to do that, and it will take you here. Enable, you know, I don't have to write all the enable, but if you hit en and then the tab sign, it will finish enable. So we are on enable. From the enable, there's a lot of things you can do, and by hitting the question mark, show you all the commands that you actually can do here. Let's keep ourselves a little bit working with Cisco, because usually Cisco, when they want to ask you, they will ask you from their available resource on the website. So the first thing they do is the clock set. So you have to do clock set and then question mark. Give you the option to give it at the hours, minute, and the seconds. You just have to enter any hours, and hours, that mean you have to enter them in like this format: 16, like 24, and 15. Oh, sorry. And then after that, sorry, you have to enter right here. See, 3 March clock set, and then you have to enter the day and the 3rd, for example. Month, we'll say May. I don't know if you take it as a May or as a number. We'll see. Not recognized, I mean I have to write May 2014, for example. Here we go. All right. So you see how, like, you know, I couldn't remember if I have to write May or 5. I just did the question mark, and after the question marks tell me that this unorganized command. So then I changed to May and give him the end. Now to see if our clock is right, you have just to go show clock, and it'll show you, you know, May 3rd. That's what we enter, 3rd May 2014. So that's how you set the clock. And then I know we have to go to through Cisco, but Cisco exam topics, but on their website that was the initial configuration. Now how you set the host name, you have to go to the configuration mode, which you have just write conf t, which is config terminal. Where is that? I just here, configuration terminal. So I just put the abbreviation for that as config t. Will take you to the configuration. There's a lot of, you hit the question mark, there's a lot of other command you can do from there. Conf t, you write host name and then give it a name. Like, you know, usually if you're going to work in a long environment, in the big environment, sorry, and you have a lot of switches and equipment on the network, you have to put some kind of naming systems for your, for example. So this, like, you know, the office building switch, for example, for Texas TX, for example, anything. So just in case one day, like, you have a ticket from your NOC, or you have a ticket from your software that's monitoring your network equipment saying that, you know, Office Texas is down, it will show you the actual host name, and it will show you the IP address. But sometimes there's a lot of IP addresses in your environment, you just don't remember, so you can't just put a name that's actually you can remember. Management IP address. So I want to talk about the management IP address. I'll talk about it in Visio a little bit, because so you, for example, I'm trying to insert Yeah, I will just keep inserting more switching. For example, like 3 switches, 2960s, and I'll open more stencils for access layer switches like 3750s, and like you get 3750G. That's like your, I'm building like some kind, that's the front view. I'm kind of like show you how exactly the network going to be look like, the network installations in your environment. So usually if you have like 3 or 4 or 5 or 10 2960 switches, and that's all the back view, what I'm doing, I have to find the front view of 2960s. 2960s. 29 Cisco 2960. That's the router which we're going to use. Okay, yeah. So we have 2 or 3 2960s right here. We are connecting these. Let's get a connector. We have like fiber connections from their fiber interface to here. Usually 3750s, there's a model of 3750s that actually have all fiber connectors, so even its Ethernet is fiber. And then you bring a router, Cisco router. That's the front. Cisco router, usually you have to connect the rear of it. Here. And then from the core switch you connect, really? Connector, what the hell? Why I'm not doing the connection? Let me, but I'm still, okay. And you connect this to your network. Right, so this is a network, for example, like in Texas or in California or somewhere, and you're trying to manage the switches from Indiana. Like you have an internet circuits right here. Let me get something for the internet service. You're trying to, how you can access the switches, like in general, just the 2960, even 3750s. The cloud usually represents the internet in the video. So if you're coming from the internet or from the outside circuits, so you're sitting on the internet here and trying to access your switch. Of course, you have to have, that's not, maybe not internet, not accurately, but can be an MPLS circuits, and you have an internal network deployment, so you have actually a routing information available. So what you're doing, you have to have some kind of an IP addressing systems for all of your equipment so you can access them. Just keep in your mind, the IP addresses that's going to be assigned to a layer 2 switch, it is for management only. The layer 2 switch, it don't know how to forward traffic depends on IP. It's just looking at the MAC address and forward it to the upper layer, which will be here in core layer switch. It's layer 3 switch, and the layer 3 switch will look on the IP informations. So this switch will assign him an IP address, and that IP address will be a management only. How we can do that? We can do that because for example, I'm trying to show you something. If we are connected this through its upper link to show IP interface brief. That's the command. You don't have to do if you are in the first mode. Now we are in the configuration mode. You have to have 2. If you see that we have the first 2 Ethernet, they're down, which is the original port. If you remember that we added the 16 slot port to the switch, to the router, and we have starting from fast 0/1 all the way to here, they're the switch port. So we'll work with the switch port. So to access inside the switch port, you have to write interface, the interface number 1/0, for example. And then now if you again want to give him an IP address of 192.168.1.1 like 1.1, 255.255.255.0. We'll go through the IP address more in the routers part in the next, I think, couple videos, but just trying to show you that the IP address, this right IP address is internal. I think we talked about the internal and external IP address. We'll talk about it more. And this 192, the mask is 255.255.255.0. If you hit enter, we'll show you that IP address might be not configured on layer 2 links. That's what I'm trying to show you. You are in a switch interface and trying to ask him to put an IP address. He goes like, no, hell no. I'm layer 2. I don't know what the hell the IP is. It won't accept it. So how you can actually add an IP address to the switch is by adding in that IP address to the VLAN interface. We're going to talk about the VLAN, but there's what's called VLAN. The VLAN is actually the logical segmentation of the subnets to a different network on the same switch on or span a different multiple switch. So if you're having, like, for example, on the same network right here, and you have a different department, like you have finance, you have HR, you have technical, a lot of departments, and you need to separate these in different. And why we do the separation, because that's what will reduce the broadcast domain and the collision domain that we just was talking about. So we actually logically splitting the switches to a VLANs. So we call like VLAN HR, VLAN whatever. So, and every switch has a default VLAN to show VLAN. Oh, because we are on, sorry, and because we're on the router, that show VLAN now works. So I think we have to go on the VLAN database. Yep. Show. What's the current? Yep. There's VLAN 1 is the default VLAN. All the other VLAN that you're not going to use, but you're using VLAN 1. Show VLAN dash switch, I think. Yep, that's what actually going to show you the switch. Because usually, if in the normal switch, you just do show VLAN, you don't have to dash switch. And I'm saying here dash switch because, as I said, this router. And actually, next time I'll download Packet Tracer, will make it a lot easier to explain. So here we see that we have the default VLAN and has all that interfaces from just the 16 interface. Don't have the 2 interface of the router because they're a routing interface. So 16 interface. So to configure IP, config T, you have to give him interface VLAN and the VLAN number. And now give him IP address 192.168.1.1.255.255.255.0. Here, take it. Exit. Show IP interface brief. And if we go all the way to VLAN 1, we can actually see the VLAN is up down. And why is up down? Because it's not connected to anything. All of interfaces is up down. Whenever we connect any interface in that VLAN to anything and comes up, the VLAN will comes up. IP default gateway. Okay, so if you wanna put a default gateway on the for example, if you have the switch right here and you have a router and you connected the router to the switch, like here, connection is here, just still from the fast Ethernet to the fast Ethernet, for example, and you have to operate. But on this router is connected, for example, to your company, like this. I'll just added another switch, just trying to explain how multiple networks look like. Okay, 1, 2, just want to connect to it because I have to configure something. Just let's assume there is a cloud in the middle. So if you're, for example, trying to access this switch from here, you have to have some kind of routing between the two networks, because this right here on the right, on the left, is a network different than the right. So any packets, for example, if you want to telnet to it to manage it or anything, any packet that you send from switch 1, you have to tell the packet if you want to go to R1, which is R1 in our case is 192.168.1.1, and we'll assume that this here is 192.168.1.2, and on the other side we have a different network of 192.168.2.1, and here we have 192.168.2.2. You have to tell the switch. If you want to go back to switch 1, you have to go to 192.168.1.2. That will be its default gateway to send the traffic back whenever you don't have any entry in its routing table. So send the traffic back to it, and R2 is supposed to have a route back to switch 1. And the way we'll talk about that more in the switching and the routing, sorry. And with this, you have just the conft IP default gateway, and you tell 192.168.1.2. Bam, that's it. Show IP route will not accept this supposed. Here we go. It was not going to add it. That's in the routing table. That's just for itself to send the traffic back to the destination. Local username and password. So if you want to access this, you have to have a username and password for security reasons. So just like if you have two users trying to access, one is not authorized, he's not supposed to have username and password. Let me see what kind of username and password he's talking about here. Okay, so local username and password, and then enable secret password, console VDY logins, txt. Okay, let's cover this. To configure a password, you have to go to conft and type username and give it a username. For example, username techpix, and then you have to give it privilege. There is 15 privilege levels in Cisco. Privilege 15 is the highest. That's the administrator who have all the privileges will be privilege 15. Privilege 1 is read only. There is good documentation on what the privilege can do in Cisco. Go and look them up, and then you have to do a password like Cisco 1234. Okay. Now I think we cannot tell it to ourselves because the VLAN is not up, but let's try. Yeah, because the VLAN is not up. I'll do it next time before the record. I'll do a network where we actually have the VLAN up, and we'll try to tell it. I'll show you how to use the username and password. Okay, a very long video. We'll finish later. Thank you for watching. See you next time.